So there's your exam scores from 60, I put them from 60 to 100. 100's over there on the little heating element of the room. So based on that, you can see the range, yes? The range is pretty visible. Here's Bert's range. All the way over here. And here's Ernie's range right here. Very, very tight compared to Bert's very, very wide. Of course, the problem is that it only depends on the endpoints. Can you think of a way to quantify the inconsistency or consistency of Bert or Ernie based on that entire graph using every single data point? Any ideas? Think about it. Think about it. Any ideas?
Say that question again.
Sure, absolutely. So Katie gave us a fantastic measure of variation or consistency or inconsistency based only on the smallest and highest values. Can you make up one that's based on all the values? In other words, it's one that uses all the values.
You could measure the distance between each of the data points.
Oh, so like this guy here?
Yeah.
And then now when you say, wait, hang on a second. We're sitting up here. Tell me your name.
Lydia.
Lydia, I was going to guess Joanne, not even close. Damn it. So Lydia, when you say each of the data points, do you mean that distance, this distance, this distance, this distance, this distance? Do you mean like that?
No, I mean like that one between 1 and 2, and then 2 and 3, and 3 and 4, and then 4 and 5.
Oh, okay. I like that too. So in other words, so that one, that one, that one, that one. And then do what with those?
I don't know, I only got that.
Oh, that's a very good idea. I like it very much. What should we do with those?
Average them.
We could average them, yes? We could average them, and then we could do that. That was easy. It's all one, right? One. Very, very good. And average those, and I think it stands to reason that these average would be higher than these average down here. Can anybody think of I love this, Lydia, by the way. Never actually heard this before. This is a measure that does not exist yet. Well, it exists now. Why isn't it used? Can anybody think of why it's not used? I love this, by the way. I love this, but it's not used, and I can think of one reason pops to mind as to why it's not. Actually, two reasons pop to mind. What's one reason? Think back to my extreme example from before with Bert's scores if I changed them. Can you see what the argument would be against doing it this way if his scores were 100, 100, 100, and 61? The same skewed average would occur, wouldn't it? Because of that 61 being the outlier, Janelle, you brought up earlier, that 61 would still draw the outlier out and give us kind of an unfortunate variance. Not to mention the fact that if the test scores were far away from each other. So for example, suppose Ernie is wickedly consistent and also wickedly consistently crappy. So suppose his scores were like 39, 40, 41, 42, 43. Hey! Wicked consistent and wickedly crappy. That measure that you're using doesn't take into account that average at all. It compares them apples to apples if they're apples and oranges. So Lydia, although I love it, nobody uses it. Damn, it's good though, I like it. Distance in between, that's good.
Can you take out some of it in the lower?
You can do that. You can do a trimmed variance. Nobody does that either. And part of the problem with taking data out, did anybody feel squirrely about taking the data out over here? You only have 5 data points, you're throwing 2 away. It's like, oh God. Imagine these data points cost thousands of dollars to get, and you're like, it's an outlier. Are you sure it's an outlier? Or is it just the smallest one? That goes back to another discussion we'll have later on. So leave them all in, and how can we measure it? Shanley, what are you thinking? Lydia, thank you. I'm sorry I have to erase it, but wonderful idea. What are you thinking, Shanley?
Maybe percentage?
What? Percentage of what?
All those tests, if you add them all up, they equal 500, which was 100%.
His average percentage rate?
Yeah.
Kind of like how you would...
But that is that the same as just an average? Because, I mean, I guess what you're assuming is you're assuming they're out of 100, which is totally fine. Like, you can make that assumption. But if you average the percentage, it's the same as averaging the scores themselves since they're out of 100. Does that make sense?
Yeah.
Sarah, what are you thinking?
Well, I don't know if it's like... Lydia? Was it? Oh, so you would take the range, so you would measure the range from the first one to the second
Uh-huh.
one, measure the range from the first one to the third.
Third.
And then average the ranges of those? Or do you
And that
do
is,
with that?
it's similar, that's where I was going first with what Lydia was saying, was that, like, there's actually 10, if I'm doing the math in my head correctly, there are 10 different distances you can measure on this. You can measure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you can see how that's going to get a little ridiculous as your sample size starts going up. It's a cool bit of mathematics called a combination, which we'll study in this class as we go through the class together. But again, I think the problem with that is, well, the big problem, only because I do statistics all the time, is nobody uses that. I'm not saying it's not valuable, I'm saying nobody uses it. And here's the thing. Let me ask a question a different way. Can you think of a way of tying consistency, rather than treating consistency independent of what we already know, center? Can you think of a way of tying consistency into measures of center? Cody, what are you thinking back there?
I'm not really sure. Well,
Go ahead!
Going with something that started with an L. But
Lydia.
Yes.
Lydia.
But she was going with measuring the distance between each of them. Instead of upon themselves, could you measure it off what the average of like
Boom!
what it is?
That is a great, because now, not that you guys have great ideas, but the problem with treating the variance in the way you're doing it is, you're treating the variance in isolation of what you already know. You guys over here made a claim that Bert and Ernie are the same, yes? Okay, we don't have to throw that away. Let's slap that onto the graph. Okay, so here's their average. This is average is Ernie, Ernie's average is Ernie. Ernie's and Bert's average of 81. Now hopefully you can see, plate of cookies, if you had to balance it, plate of cookies, balance both of them. Balance both of them, fair enough. One way of measuring variation from this average would be to take the distance not of a point to another point, but how far that point actually is from the average. Does that make sense? So let's take a look at it. Let's take a look at it. Let's do Ernie's first because he's easy. Okay, what's the distance from Ernie's 80 to his 81? This is one unit, correct? 1 unit. How about 79 to 81? 2 units. 82 to 81? 1 unit. 2 units. And how about the 80 itself, or 81 itself? 0 units. So you've got 2 units, 1 unit, 0 units, 1 unit, 2 units. What's the average?
0.
How about 1.2, I think? If you add all those numbers up and divide by 5? 1.5?
1.2.
1 if I did, I'm doing it right. 6 divided by 5, 1.2. Yes, thank you, good. Don't trust my math. Never trust my math. Especially when I do it in my head. Bad idea, bad idea. So that's a nice one. So if we do it that way, average distance from X bar, we get a number of 1.2. 1.2 what? What's the unit on that? 1.2 points on an exam, yes? Because this is a 2-point difference, this is a 1-point difference, that's a 0-point difference, that's a 1-point difference, that's a 2-point difference. That's one way of measuring variation, which is totally fine. Unfortunately, there is no shortcut for that technologically, except in Excel. And the reason there's no shortcut for it technologically except in Excel is nobody actually uses that, which is unfortunate. You'll learn more about why as you go through 244 with me, if you go through 244 with me or Donna. But I don't want to throw away this idea that Cody has, because this idea at its heart is a good thing. At its heart is a good thing. What I want to do is kind of walk you through, let's get it started before break here. I want to walk you through the actual measure that takes Cody at heart, what you're describing, but it's what's actually used in the world when we actually measure this thing called variation. But first, before we go anywhere, let's make sure we understand what we're doing, okay? Let's make